In this video, we are going to continue with the concept of concave, convex. Now, I'm going to start by doing some basic questions and let's see if you're able to get through those or not. So my first question to you would be, you have to tell me whether the following are concave or convex. Question number 1. F of x is given as x cube. Let's solve this out. So if f of x is x cube, f dash x will be 3x square. F double dash x will be 6x. 6x would be greater than equal to 0 if x is greater than equal to 0. 6x would be less than equal to 0 if x is less than equal to 0. Therefore, the function is neither concave nor convex because it's not completely greater than 0 or equal to 0, not less than equal to 0, equal to 0. So the function is neither concave nor convex. Right? Now, this is the first part. Let's see if you're able to solve the second part. I'm going to give you the function as e to the power x and see if we can solve this. So here, f dash x would be nothing but e to the power x. F double dash x would also be nothing but e to the power x. Why? Because the differentiation of exponential is the same. And I know that e to the power x is strictly greater than 0. So which implies that this is strictly convex. By the way, just a small thing if we want to do that. If I take y is equal to e to the power x and I take log, exponential log, okay, on both sides. Just a small thing that I'm doing. Then ln y will be ln e to the power x. Ln y will be x. Okay. This is in a way the inverse form. Do we agree? How do you get an inverse form of anything? Very simple. We have done this as part of the range, domain, sets, etc. If we write y is equal to x plus 5, then, if this is my function, y as a function of x, then the inverse form is x as a function of y. Or we can write the inverse form as this. So this is exactly, that's the inverse form. When I write x is equal to y minus 5, in a way, what inverse form I'm talking about? If I'm talking about the ranges and domains, the inverse forms, right? So we know that this is an inverse form. Now, let's pause in for a second here. And supposedly, I tell you that x is equal to ln y. And I ask you if this function is concave or convex. Let's try this out. If x is equal to ln y, then if I differentiate this function, this will be 1 by y. This will be its first differentiation. If I double differentiate this function, this is going to be minus 1 by y square. And this is going to be less than 0 for all values of y. It's not defined at 0. I understand that, but otherwise it's less than 0. So can I say that this is strictly concave? This is the inverse function. So the inverse function is strictly concave when the actual function was strictly convex. Let's take another case and let's see if this actually holds true. Can we make this into a theorem? Can we make this into a proof? So I am going to take my function as y is equal to x square. I know that f dash x is equal to 2x. And I know that f double dash x would be 2, which is greater than 0. Hence, it is a convex function. Now, let's find out its inverse. So, y is equal to x squared gives me x is equal to root of y, which is nothing but y to the power half. So, g dash y would be half y to the power half minus 1, which will be half y to the power minus half. And g double dash y would be half into minus half into y to the power minus half minus 1, which would be minus 1 by 4 y to the power minus 3 by 2. This part, I'm just going to rewrite it here. So, you know, g double dash y would become minus 1 by 4. So, you know, y to the power minus 3 by 2 can be written as y to the power 2 by 3, right? Minus. Now, this is pretty simple, right? So, I am finding the square of y and then I'm multiplying it by 1 by, I'm making it to the power 1 by 3. But the square of anything is always positive. If it is positive, whichever root you want to find out will be positive. So this part right here that I have is positive. Being multiplied by negative gives me negative. So can I say that this inverse function that I just have will be concave? And in fact, strictly concave, right? Because it's strictly negative. It's not equal to 0. And unless it is for y equal to 0, right? So try it for the cases and check if a function, and you know, we will see if you're able to prove this for a few more examples, that if a function, and see if you get any counter to it. If a function is concave, then its inverse is convex and vice versa. This is something which you have to try for other examples. I've given you 2. And see that if you can prove this mathematically. But what I'm going to do is I'm going to prove another theorem for you. So I'm going to prove if f of x is concave, then f minus f of x is convex. I'll prove this, and what you have to prove in the background is if f of x is convex, then minus f of x is concave. The two are going to run very similarly, right? Very similar to each other. I'm going to do one side and you do the other. So let's try this. I am saying f of x is concave. Since f of x is concave, it means f double dash x would be less than equal to 0. Now, multiplying both sides by -1. And because I'm multiplying it by -1 on both sides, remember, whenever you change sign, whenever you multiply something by -1 or any negative thing, this sign also gets altered. So I'll give you an example of this. When I say 4 is greater than 3, -4 is less than -3, of course, right? Because when we go down the number line, -1 is greater than -2, is greater than -3, is greater than -4. You know, the sign goes like this. 1 is greater than 0 is greater than so on. So, you know, the moment I multiply by -1 on both sides, the sign that I have here gets altered. So I'm going to do exactly same thing here. F double dash x is less than equal to 0. I multiply by -1 on both sides and I get minus f double dash x greater than equal to 0. But if minus f double dash x is greater than equal to 0, this automatically implies that minus fx is convex. So we started by a function which is concave and we came to a function which is convex. You have to do exactly the opposite in this case.